So here we have a balanced reaction. This is the reaction that takes place when you put an Alka-Seltzer tablet in water. The reactants, the sodium bicarbonate and the citric acid, are both part of the Alka-Seltzer tablet. So why does the Alka-Seltzer tablet not undergo the reaction until you put it in water? All the reactants are there in the tablet. Why doesn't it react in the box? Everything needed to do the reaction is already there in the tablet. Yeah. Dissolving allows for the motion to provide the collisions that are necessary, right? In the solid, they're sitting there vibrating. That's not enough motion. They need to be able to smack into one another with enough energy to break some of the initial bonds to then do the reaction and produce the product. So the water is not a reactant. It's the solvent. It facilitates the reaction, right? That's why we talked about solutions at the end of last section, because we understand that for reactants to collide, usually they have to be dissolved in something so that liquid allows for motion of the particles and the collision. So we put the Alka-Seltzer tablet in water, the molecules separate, they start moving around in the water, and then they hit one another and the reaction occurs. So a tablet has a specific amount of sodium bicarbonate, a specific amount of citric acid. If you're taking Alka-Seltzer to calm an upset stomach, is it more likely that the bicarbonate or that the citric acid is the excess reagent? Does it make sense to put excess acid in your stomach if you're not feeling well? No, probably not, right? So most likely the company has designed this tablet to have the citric acid and the sodium bicarbonate react together to produce the fizziness. But after that reaction is done, the citric acid should be gone. It shouldn't still be there. So we can predict that the limiting reagent is probably the citric acid, but we want to find out for sure. So what we showed in the last example a little while ago was one way to determine the limiting reactant is to determine which reactant will produce less product. That's one I'll run out of first, and at the same time, when I calculate how much product that limiting reactant will give me, that will also be the theoretical yield. So in this case, I'm assuming that the reaction is complete, but I want to know how much CO2 will form. So really, this should say, what's the theoretical yield of the CO2? How much of it is going to form? So if we want to know that, we can say how many grams of CO2 could we make from the 1 gram of citric acid, and also how many grams of CO2 could I make from the 1.700 grams of sodium bicarbonate. So I'll just call that carb. I need to do 2 conversions, because at this point I'm not totally sure which is the limiting reagent yet. One of these calculations will give me an amount of CO2 that is less than the other calculation. That is the maximum amount of CO2 that I can make because it's coming from the limiting reactant. So I would set both of these up to start by converting to moles, because I always have to cancel grams of a substance to get to moles, so that I can use the coefficients in the balanced reaction as a relationship to convert from one substance in the reaction to another substance in the reaction. So for the citric acid, I've got a total of 8 hydrogens there, 6 carbons and 7 oxygens. So that gives me 192.12 grams per mole. The sodium bicarbonate, I've got 1 sodium, which is 23 plus hydrogen plus 1 carbon plus 3 oxygens gives me 84.01 grams per mole. So I'm converting these both using their individual molar masses to get to moles of that substance. so that now I can convert to the substance I'm interested in, which is the CO2. And I use the coefficients. So for the citric acid, it's a 1:3 ratio. So 1 mole of citric acid for every 3 moles of the CO2. For the sodium bicarbonate, it's a 3:3 ratio or a 1:1 ratio. So 3 moles of CO2 from 3 moles of the bicarbonate. So if I was just asked for the theoretical yield, I could stop there, because the theoretical yield is a quantity, the maximum amount of product I could make. Quantity of product, if I stop here, everything cancels except moles of product, and moles is a quantity. So if I wanted that, I could stop there, but this specifically asks me for grams. So I need one more step to convert the moles of CO2 into grams of CO2. And so that substance has 1 carbon plus 2 oxygens. That's 44.01 grams per mole. So that will cancel the moles of CO2, and I'll have grams of CO2 for each. So when I carry each of these through, the one that's lower will be the maximum amount of CO2 I could make. This one gives me 0.68. I have 4 sig figs, 7.2 grams. The other one is 0.8906 grams of CO2. So this one is the maximum I can make, because what I've calculated here is I could make 0.8906 grams from the amount of bicarbonate I have, but I only have enough citric acid to make 0.6872 grams. So when I make that 0.6872 grams, I'm out of citric acid. I can't make any more product. So that's the answer to C. That's the theoretical yield of product. That's the maximum amount of product I can make. And the limiting reactant is the citric acid, just as we suspected. It's the one I run out of first, because it's the one that will only allow me to produce a less amount of the CO2. So how do I answer part B, which says, what's the mass of the excess reactant left over? So I've got my excess reactant is the sodium bicarbonate, and I've got 1.700 grams of that. Some of that's going to react, but that was excess, so some of it will be left over. How do I figure out how much is left over? Gotta get rid of some of this stuff so I can set that calculation up. If I want to know the amount left over, it should be the starting amount minus the amount that reacted. So for the amount of the bicarbonate left will be equal to the starting amount minus the reacted amount. That will tell me how much is left. I've got the starting amount, 1.700 grams. I need the amount that reacts. That's going to require conversion. So if I'm forming this amount of CO2, how much bicarbonate actually reacted? If I have information about one substance, I want information about a different substance, I just need to do a conversion. So I would say, how many grams of the bicarbonate actually reacted if I got 0.6872 grams of CO2? Didn't leave myself enough space, so I'm going to have to get rid of this. So I've got CO2, I want bicarbonate. So I will first convert to moles. Grams of CO2 per mole. That way I can use the balanced reaction as my relationship to convert one substance to another. So 3 moles of CO2 requires 3 moles of carbonate. So 3 to 3 relationship. And then I erased it, but the molar mass of the CO2 will allow me to get, or the carbonate will allow me to get from moles of carbonate to grams of carbonate. So just what that was the sodium plus a hydrogen plus a carbon plus 3 oxygens, 84.01. So that conversion, just very similar. I can convert from any substance into the reaction to any other substance in the reaction by using that key relationship that comes from the balanced reaction to get the units I want. So that's going to be 0.6872 divided by 44.01 times 3 divided by 3. That cancels, so times 84.01. And I get 1.312 grams reacting. That's the maximum amount that could react. Assuming that the reaction is complete, I would subtract that from the initial amount to figure out the amount left over. Just do it in my calculator. 1.7 minus that answer. 0.388. That's part B.